Okay, everybody, thanks for coming and welcome to this session on building geoservices that scale. I'm Lawrence Moroney. I'm a developer advocate at Google. I work on a lot of different technologies at Google, but today I'm going to be talking about some of the geoservice and some of the back-end services that are available from Google. My co-speaker, Elena, unfortunately can't be here. We're going to be talking about an app that we were building, and Elena was user 0 for this app, and unfortunately she didn't use it correctly, and we'll see why that ended up delaying her actually being here. So what we want to think about is, like, say you are a business or you're a startup and you want to build a new app, and you have a lot of requirements for this app that you just can't compromise on. And one of these requirements is that you've got business logic that's very precious to you, and you do not want to distribute this business logic in an app where somebody could decompile it and maybe like filter through it and figure out what you're doing. I'll give an example. I used to work in financial services, and we had like a number of processes in financial services where we would look at a company, we would look at the fundamentals of that company, we'd feed them into a machine, we'd get a value out of that machine, and then that value would help us estimate, is this company doing well? Is the share price too high? Is the share price too low? And that stuff, those analytics were very precious to us, and there was no way that we would distribute them. So it's a pretty common scenario that you don't want to distribute this kind of stuff in an app. You need something on a back end that would be able to scale. Another one that we hear a lot at Google is that we have a number of APIs that require like an API key, and that API key is used, for example, to like monitor your usage of it, so that if you've got a free limit, so that you can go up against that, or if you're charged, just to make sure that you don't get overcharged for things that you're using. And again, if your API key gets distributed with your app, people can decompile it and then start using your API key, and that's being a little bit naughty. A lot of people have requirements around, we don't want to distribute the API key, so we need some kind of server-side logic for this. So we have all of these requirements, and I'm thinking, when we were putting this session together, we were saying we really wanted to make it feel like it's a real business. We're going into a new venture. We're building something new. And we had a number of scenarios that we wanted to look over. But one of the scenarios that came up constantly was that traffic is always a problem. How was it getting into Shoreline today? Were you guys okay, or did you have a traffic jam? A traffic jam? Yeah. And particularly in Silicon Valley here, the traffic can be really bad. But one of the things that we discovered when we were doing our research is that nothing can ruin your day like a traffic jam caused by a zombie invasion. So we said, okay, what if we built an app that would help people, not get stuck in traffic jams caused by zombie invasions, or if you had to go on that route, that you could, pack the appropriate material like the odd shotgun or two, or those kind of things. So we said, what if we built an app where people could then, if you see a zombie invasion or if you see zombies on the road, that you could report these zombies. These could get fed into a system. And then when you're using our app, this is our wonderful billion-dollar idea app, when you're using this thing, you could say, hey, right now I'm going to travel from here to a particular address. Let me check if there's a delay on the way. And if there's a delay on the way, then maybe I should go take a look at the database of zombie reportings just to make sure that, that I need to pack a shotgun, or I need to pack whatever it is to help me get away from these zombies or get around these zombies. And then we also said, what, if you're going to be doing that, we also need to attribute it a little bit. So let's have people report something, but let them attribute, like, so maybe it could be 2 or 3 zombies, or maybe it could be 100 zombies, or maybe the zombies are breaking out into a Michael Jackson dance party, any of these things. So like all of this kind of information, like we need to be able to capture and to be able to store. So, and then the other thing is we decided to get a focus group together to help us figure out a name for the application. And, we spent months and months and months, and lots of people in the focus group, and they told us we should call it Zombie Maps. Go figure. So, but seriously, like, okay, I mean, it's a little bit of a flippant scenario, but when you think about when you're building an app like this one, you'll generally have an architecture something like this. The heart of your business logic, your analytics in my financial services example, are this service box right in the middle. And this service box might have to consume third-party data. So in the example that I'm showing here, we're consuming geodata from Google, but in the financial services example, you might be consuming financial information from stock markets, all those kind of things. So your service has a lot of smarts in there, has analytics, has your business logic. If you've got API keys, if you've got any of that kind of stuff, you would put it in there. And then, like I said, like the box at the top, the Google Maps box is this third-party stuff that we're consuming. But then you'd also might want to wrap that service with some kind of an API level. Well, of course you would want to wrap it with some kind of an API level because you want to be able to consume that service and you want to be able to build mobile apps or web apps that consume that service. And the typical pattern will look like this, where I have mobile apps on the left, they're coming through the internet, they're hitting an API. That API then is the front door into my service for those apps, and then the service itself is doing all the smarts. It's managing data, with that database, it's pulling in third-party content, it's applying business logic to all of those things. So, pretty standard type of architecture here that I'm sure many of you have built something like this. But I just want to recap our requirements. And particularly when it comes to a zombie invasion, our requirements are very, very important because we need to be able to scale our app up as we need to be able to scale it up. The worst thing in the world is for our app not to work because of scale if there really was a zombie invasion, and then our customers, instead of giving us negative reviews on our app, are going to be eaten by these zombies. So we say, okay, we need to be able to scale up and we need to be able to scale down as needed. Why do you think one would want to scale down? Cost. Exactly. A lot of times when we talk about scale, we tend to think in terms of scale means our app can get really, really big, and it can get really, really big really quickly, and that's great. But if you go to huge capacity to be able to handle 10 million concurrent users or some crazy number like that, and then the zombies are all gone, and you're paying for this capacity, it's not very good for you as a business. You want to be able to scale down very, very quickly. So we're thinking we want a technology, we want to be able to build this app so that right now, thankfully, there are no zombies, but should they turn up tonight, that we're going to scale up, we're going to handle the capacity of reports of these zombies, getting details back about these zombies so we can navigate around them, and then when the zombies are gone, we scale and we go away from all of that one. And then, of course, as I mentioned earlier, our other requirements, storing sensitive business logic, data such as API keys and that kind of thing off the device. So we started, the fans have gone off. So we started thinking about this and how we would build this. And if you've used Android Studio has this handy-dandy little tool for creating cloud backend modules. And this is the wizard on this one. And what this does is it will create an App Engine backend, and it will stub out the App Engine backend for you. And then it will create an API level wrapping that App Engine backend. So if you remember my 3 boxes on my diagram, this is 2 of them being built for me right now. So this is great. This is a really, really good start for me to be able to do things. But then there was my data. So there was that cylinder over on the right of the diagram. How do I store my data? How do I retrieve my data? And how do I make it scale? If you guys recognize this icon, this is the icon from Cloud Datastore. And what Cloud Datastore gives you is a NoSQL database that you can put as the back end. And as you scale up your App Engine instances, it will scale up in capacity to meet. And as you scale down, it will scale down to meet also. So it seems to be really, really perfect for our requirements to use these things. So let's go back and take a look at our architecture again. So here was our architecture, our mobile devices on the left, our API, our service tier, our data on the back end over on the right. And then we could say, okay, with the API, we're using cloud endpoints. Remember that wizard that I showed you earlier on? That was the cloud endpoints wizard that created the API wrapper, which are the endpoints, plus the App Engine backend for me, so that I can write my service in App Engine. And App Engine runs Java, Python, PHP, Go. So I can start writing business logic in these. Because I did it in Android Studio, I wrote my backend for this application in Java. And then the database itself is this NoSQL storage, so it's the Cloud Datastore. So it seems like I have all my pieces here to be able to scale up and down as much as I need to, and only pay for the services that I'm actually using, which is, particularly if you're a startup and you're burning through seed capital, that's very, very appealing. You don't want to budget for crazy amounts of infrastructure if you don't need crazy amounts of infrastructure. You budget for what you use. And then, of course, the last thing for this was we said we wanted to incorporate a third-party API. And in this case, the third-party API was data coming from Google, which is that box at the top. And the data that we used from Google and we decided to use was, you've probably all seen something like this. This is a Google map, and it's showing travel times. Those red blobs around San Mateo, where traffic is slower than usual, or much slower than usual. The orange blobs is where it's a bit slower than usual. Now, this data has to come from somewhere. And we said to ourselves as we were building this application, this is great. So we know we can get this data. So if there really is a zombie invasion and traffic is being impacted by it, there's an API somewhere that we can call to see if there's going to be a traffic delay. And that API is part of the Google Maps Web Services APIs. Now, there's a whole bunch of these APIs. And my co-speaker was the expert in these, and she was going to talk about them. Unfortunately, she's not here, so bear with me. One of these that I mentioned was the Directions API, so that you can get turn-by-turn directions between A and B. The one that we're using in the zombie maps is the Distance Matrix API. And what that is you can feed it a number of sources, and you can feed it a number of destinations, if you excuse the pun about feeding. And then it will tell you all the different routes between them, how much it would take, and then under various models, like are you walking, are you driving, are you flying? I don't think there's flying. Are you walking, are you driving, are you busing? It will tell you the time. It will also give you predictive models based on our knowledge of the history of these that's been fed into a machine learning algorithm as to say, okay, usually on a Saturday, this might be a 20-minute ride. It's actually going to be a 25-minute ride. And that's the perfect signal for us to say, haha, there's a delay here. Let's see if there's going to be zombies at that location. Geocoding, as we can understand, is typical geocoding. It's turning numbers into an actual location, into an address, that type of thing. Places API allows you to understand places that you're around. The Roads API allows you to snap latitudes and longitudes to real roads, because sometimes latitudes and longitudes fed by your phone are very inaccurate. Anybody here from the East Coast? Okay, so like on the East Coast, you know, a lot of the highways have service roads. And then sometimes when you're driving on the highway, your phone thinks, based on the latitude and longitude, that you're on that parallel service road. That's the kind of thing I'm talking about. The Roads API helps you snap to the real locations. Elevation, time zone really speak for themselves. But these APIs, they give you the whole world in your hands. No. Thank you very much. So going back to our architecture, you know, here's what we're building. You know, we really want then the ability for people to report zombie sightings. So let's take a look at the API that we have for that. So if you've ever built in cloud endpoints before, you'll build a method into your business logic tier, and then you create some metadata for that method, and that effectively turns it into an API. And here's my API for that. It's very, very simple. I use the yellow tags are the ones to really take note of, the API and the API namespace. So once I put them, and once I specify the classes that are implementing these, then when I run this on App Engine, I'm going to get tools like this. So if I go into the API, so if you open up your App Engine app in the browser, it's just going to be name.appspot.com. You can go into the API's Explorer from there, and here you can see my zombie reporter API is actually shown up, just because I put that metadata into my app and it was attributing those classes. And then you can do things like testing your API. So I did a backend, you know, I did a test here where you can actually see the URL of my App Engine. So if you want to try it out now, you can see it. And so if I did this just to find zombies and to report the zombies, I know the font is very, very small here, but it's just JSON being returned back, and the JSON is where somebody has reported a zombie. This is the latitude and longitude of where it was reported, and this is the note associated with it, like too many to count, you know, they've broken out into a dance party, or some of those things. So all of these are built in if I'm building this in App Engine. I'm getting these out of the box for free. I haven't done anything other than that attribution that I just showed. And now, so when we want to save our data into, so I've created a zombie, I've seen a zombie, I want to make a report, and I want to save it into the database, this is all I have to do. This is using a library called Objectify. And Objectify, it's this Java Access API that's been built for App Engine, and it's been built for Cloud Datastore. And it makes, for me to save an entity into the database as easy as this. And it's almost just plain English when you look at it. It's Objectify, save my entity's called citing, and save it now. And it's really as simple as that. You can learn more about this library at that link, github.com/Objectify. Okay, so now I'm saying, I'm building this logic, and I want this logic to be able to scale. I'm building it into my middleware. So the next thing I want to have is the location of a zombie. So this is just a plain old Java object, as you can see. It's a public cast zombie location. I've given it an ID. I've given it a latitude. I've given it a longitude. And there's just a string for attributing this so that I can give some details on the zombie, and I have some getters and setters. But then I just added these attributes to it. This is the only requirement in order to get the benefit of Objectify that I just shown. Your class you specify as an entity in Objectify. Each of the fields that you want to store, you put as an index. And then you have to have, the only major requirement is you have to have a long called ID, and you attribute that as ID. So my plain old Java object, to turn it into something that can be serialized and scaled, this is all I had to do to it. Pretty straightforward, pretty easy, right? Okay, cool. So now when it comes to storing this data and the Objectify line that I showed you earlier on, again, it's just a straightforward method. In this case, I call it insert zombie citing. I'm passing a citing to that. My API is handling the transfer over and back between my Android or iOS app and the actual backend. And all that's going to do is call that line, Objectify saved entity citing now, so that I can store my citing in the database. So the next thing is I need to write something that says, okay, if I think about my business logic, I'm saying I need to go from A to B. I've detected that there's a delay between here and there. I'll show the code for that in a moment. And if there's a delay between here and there, I need to present the user to say, maybe we should find some zombies between here and there to see if that's what's causing our delay. So here's how I would query the database to do that. It's a find zombies method. And all it is I'm going to create an array list of these zombie location types. And then in Objectify, I'm going to load, and I have to specify the type that I'm loading in, because earlier when I stored, they were zombie locations. So now when I'm taking them back out, they're still zombie locations. And there's only one constraint when using this that was a little bit of a pain, but it's not too bad. And that was if I want to filter on values, I can only filter on one value type. So you can see here, I'm just filtering on longitude. So if you think about, I have a latitude and longitude for my source. I have a latitude and longitude for my destination. So I said, what I want to do is I want to draw a rectangle around these and find any zombies within that space. So I'll start with the longitudes, and I'll filter on the longitudes. So I get a filter of all my zombies with longitudes that are within this space. And then once I have that in memory, then I just have to go through these and filter them to find the ones within this space. So it's a little bit of a constraint. I can only filter on the one field. But once I've done that, I have a set in memory, and it's pretty fast for me to just iterate through that and filter out what I need. And then I get my collection of zombies, which I call the zombies, and then I return the zombies. And at this point, I need to pause for a second. I've been developing software for a very, very long time. And it feels like my entire career has built up to this moment and this line of code. It is the best line of code I think I've ever written in my life, and it makes me really happy. Just return the zombies. So earlier I said traffic conditions were the other thing that we needed. We needed to consume this third party for traffic conditions. And in the Geo APIs, we have this thing called a distance matrix. So all I have to do to get these is I use the distance matrix API. I call the getDistanceMatrix method on that, and I pass it a set of origins and a set of destinations. In the case of my app, it's very simple. I'm having one origin and one destination. And then I can specify different attributes of that, like my departure time. Am I leaving now? Am I leaving tomorrow? Those kind of things. My traffic model. Just for the sake of a gratuitous demo, I decided to make it the most pessimistic model here. But there are a number of ones like optimistic, normal, that type of thing. The mode. Am I driving? Am I walking? Am I biking? And then I just await the results. So I get an asynchronous callback. And then once I get it back, then because I know I've only done one origin and one destination, I'm just going to take out the first element. The first element of that is a distance matrix element that I call item. And now it's really nice that I can start going through the item and I can start querying properties on that item. So for example, things like the time in traffic, it's given to me by the API in human readable form, which might be 15 minutes. And it's given to me in machine readable form, which is a number like in seconds. So this ends up being really nice. So then in my business logic, I can say the normal time is X, the current time is Y, but because it's numeric, I can say if Y is greater than X, then there might be a zombie invasion. So here, going back to my architecture, I've done this, I have my API, I've merged this all together, I've built the service, I've built this simple logic into it. Almost this entire functionality of giving people the ability to report a zombie sighting, giving people the ability to navigate from A to B, check the traffic conditions between here and B, see if they are longer than they should be, retrieve details of any zombies between here and B and map them all out. Almost all that code for that kind of application I've just shown you. Right? It's a very simple application, I know, but when you're thinking about the amount of functionality that's in there, and it's done with like maybe 30 or 40 lines of code, I find that like really fascinating. But it's not just a gratuitous demo. I wanted to actually, it's not just a gratuitous slides. I actually want to show a demo and show this thing in action. So let me switch to the Wolf Vision. And here you can see the app is actually running. So on my app, if I, for example, tap to report a zombie, what I've done, I've hacked this a little bit. So like I've put in a preset destination, and I have a preset source, and I'm picking a random latitude and longitude between them to report it. In a real app, you would actually be just choosing your own latitude and longitude for where you're at. And if I put a note in here, something like, any hockey fans here? Yay, San Jose Sharks are playing tonight. So I've set this up for me to, to navigate down to the Sharks arena. But if there's any zombies on the way, I'll say something like, I am not sure if hockey fans, thank you, autocorrect, or zombies. So I'll put that note in there, and I will save this. So I've now reported a zombie. I have a little toast coming up there saying that it's done. So if I hit check traffic now, my destination address, this is the location where the Sharks actually play. I'm going to hit the search button, and sometimes when I demo this, it's really, really slow. And there's a very good reason for that. This time it was really fast. The reason why it was sometimes slow when I demo this is that I'm using App Engine. And remember I told you it scales up and scales down to meet your capacity? Well, if I'm the only person using this app right now, so if I hadn't warmed this up while we were waiting for the talk to begin, there'll be no App Engine instances running, so I'm not being charged anything because I'm not using anything, but the first time I do it, it'll spin up my first App Engine, and then I get charged for that capacity. So, but because I'd warmed it up a little bit earlier on, that App Engine is up and running, so I'm good to go. Now we can see here, I hope you can see it on the screen, yep, that it hit a delay. It's normally 27 minutes from here to the San Jose Sharks. It's now estimated 30 minutes. So shall I check if there's a zombie invasion? I think I should. I'll say yes. And here we go. And here's my map. And it's showing me, these were the zombies that were stored. And if I touch on them, that's a really big one. Those ones are ghastly. And I think that's the note I made earlier. I'm not sure if those are hockey fans or zombies. So this was just using the map tools that are available and the map APIs that are available for Android. I just put pins in for those latitudes and longitudes. I use a custom PNG for those pins, and I attribute them the way that I had done earlier. Okay, so that's our walking demo. And here's the application itself and how it runs. So what's next? How would you build something like this? Now, hopefully we don't need to go out and build zombie detectors. Thankfully, we don't. But if you do want to build something like this, if you do want to build something that uses intelligence, for example, about geodata, the way that I was able to use intelligence about road services and how long it's going to take in traffic and that kind of thing, go take a look at the Google Maps web services. They're at this URL. Cloud endpoints, which I used in this case in Android Studio. I literally said file new module, cloud endpoint. It gave me a wizard. And what that does is that creates an App Engine instance for you with a basic API and a basic bean that you can use to transmit over and back from that API. The cloud endpoints in Android Studio, there's a link there. And there's always good stuff on youtube.com, Google developers as well. So yes, and of course the reason why Elena couldn't be here is she forgot to use the app and she got eaten by a zombie. So just thanks very much for this.